All right, today we're going to do part 3 of section 2.3, and this is going to be primarily on what's known as the rational root theorem. So before we get to that, let's talk about what a rational number is, and therefore what is a rational root. A number is rational if it can be expressed exactly as a ratio of two integers. In other words, we're talking about numbers that can be written as fractions. So that would be things like 4/5, which of course we know is what, 0.8, right? 8/10. So those are the same number. Those are all rational numbers. The number 6 is a rational number because it can be written as 6/1, right? 1/3 is 0.3 repeating, but 0.3 repeating can be written as a ratio of two integers, 1/3. So 0.3 and 1/3 are both examples of rational numbers. And we could go on all day. 0 is a rational number because you can do 0 over any number. We'll say 0/5. Both 0 and 5 are integers, so that is a ratio of integers. Most numbers are rational numbers. So what isn't a rational number? And that, of course, would be our good friend pi. E, our natural base, remember that guy? But then the most common irrational number is going to be the square root of numbers that are not perfect squares. So numbers like the square root of 2 and the square root of 3, etc. Not the square root of 4. Square root of 4 would go up here because that's just 2. So irrational numbers are numbers that cannot be written as a ratio of two integers, and those are usually any non-terminating decimal, but not just non-terminating because 1/3 is non-terminating, but it's also non-repeating. All right. So the rational root theorem basically says this. If your function has a 0 and one of those zeros happens to be rational, now keep in mind, it doesn't have to be rational, it could be irrational. But if it has a rational 0, then the rational root theorem tells us that it is going to take on a certain form. Okay, so let's take a look at this, make sure we remember. So all of your zeros that you're going to get that are rational will be of the form of P over Q, where P is a factor of the constant term. So here's my constant term, A sub 0. Okay, so P is the factors of A sub 0. Q is the factors of the leading coefficient. So that would be this. So we take the factors of A sub 0 and the factors of A sub n and we list them all out. If our function has a rational 0, it'll be in that list. Okay? Which, what this really comes down to is, as much as we love to have a method in math that we don't have to guess and check, really what it comes down to is we have to guess and check. So what we're doing here, and because we have the remainder theorem, we can do this much faster. But essentially, if you go back, like let's just say this is before we reviewed, or go back to like algebra 1, and I said, hey, find all the zeros of this function. In other words, I'm asking you, what number can I plug in to get 0? I mean, without a plan, I guess we're going to do, well, what's f of 1? Okay, that didn't work. Let's find f of 2, and that didn't work. Let's do f of 3. Crap, that didn't work. F of 4, right? And we're going to do this all day long. And there's an infinite number of choices because we've got the decimals, we've got the negatives. We could be here all day. So, not a great plan. But essentially, that's what we have to do. Except the rational root theorem helps us narrow it down. So, what we're going to do, let's identify my P, which is 6, and my Q, which is 2. So, it's not 6/2, but it is the factors of 6. So, those would be 1, 2, 3, and 6. But don't forget, it also is the positive and the negative versions of these. Because -1 times -6 is a +6. So it's positive, negative, 1, 2, 3, and 6 over positive and negative 1 and 2. So what we want to do first, because if we need to have a plan to attack this, let's list the possible rational zeros. So that's going to be, so our P over Q's are going to equal positive or negative. Make a list. 1 over 1, 1 over 2, 2 over 1, 2 over 2, 2 over 2 is 1, we already have that on the list, 3 over 1, 3 over 2, 6 over 1, 6 over 2 is 3, it's already on the list. So we went from testing an infinite number of numbers to 1, 2, 3, 4, 5, 6, 12 because the positive and the negative. So still not ideal, but better than checking indefinitely. So now what we're going to do is we want to find out if any of these are zeros. In other words, if I plug them in, do I get 0 as an answer? But I also know a better way of doing that. It's called the remainder theorem. So if I divide or do synthetic division with these numbers and the remainder is 0, then I know it is a 0. So I'm going to come over here and I'm going to start and write 2 and 1 and negative 13 and 6. All right. So I guess I'll start. Here we go. Plug in 1. Bring down the 2. I get 2. I get 3. I get 3. I get negative 10. It's not going to work. So let me go again. 2, 1, negative 13, and 6. And I'm going to try negative 1. I get negative 2. I get negative 1. I get 1. I get negative 12. Not going to work. 2, 1, negative 13, 6. Okay, so the 1 did not work. Positive did not work. Negative did not work. I'm going to stick with whole numbers right now. So I'm going to do 2. 2 times 2 is 4. I get 5. I get 10. I get negative 3. I get negative 6. I get 0. Pretty darn happy right now. 2 is one of my zeros. Find all the zeros. One of them is 2. So I see kids now who just now go back to the starting place and now start testing these numbers, the rest of these numbers, back on the original. But I don't have to do that because what I have just done is I have found that the original function, 2x cubed plus x squared minus 13x plus 6 factors. And again, what am I trying to do? I'm trying to figure out when it equals 0. So if I could factor this thing all the way down, then I can just set the factors equal to 0. So I found that 2 works, which tells me that x minus 2 is a factor. And the factor that goes with it is 2x squared plus 5x minus 3. So now I'm not going to keep testing this because I have a more efficient way of factoring. I'm just going to factor it if it factors. And I believe that it will. So this is going to factor into 2x and x. I'm looking to subtract to be 5, so I'm going to put my 3 there to get a 6 and a 1. I want a positive 6 and a negative 1. If you check your math on that, it's going to be correct. So now I'm ready to answer this question. My zeros of this function are 2, 1/2, and negative 3. Didn't ask me for the x-intercepts, it asked me for the zeros, and so I can list the zeros. Ooh, I'll get fancy. I'm going to list them in a set. Okay. Example 2, let's do it again. Find all the zeros. First, let's list our possible. So that's going to be the factors of the constant over the factors of the leading coefficient. So that's going to give me let's see, 1, 2, 3, 4, 6, and 12 over 1, 2, 5, and 10. Positive, negative for all of that. So my list includes the numbers 1, 1/2, 1/5, 1/10, 2. 2 over 2 is 1, 2/5. 2 over 10 is 1/5, already on the list. 3, 3/2, 3/5, 3/10, 4. 4/2 is 2 on the list. 4/5. 4/10 is 2/5 on the list. 6. 6 over 2 is 3 is on the list. 6/5 is not on the list. 6 over 10 reduces to 3/5 on the list. 12. 12 over 2 is 6. 12 over 5 is not on the list. 12 over 10 reduces to 6/5 on the list. Okay, that's a big list. So we got to test, hopefully not a bunch of numbers, but if we tested them all, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I got to test 32 numbers to exhaust this list. Okay, now here's the kicker. Let's think about what we know about this function. Take a look at it. It's a cubic function. So is it going to have a real zero? Is there going to be a number that we're going to pass the axis? Yes, right? In behavior, I go up, on the other side I go down. I have to pass through zero somewhere. So the only thing I don't know is if the number where it passes through is going to be rational. If so, it's in this list, or irrational, wouldn't be on this list. So there is a chance, and I have not done this yet, there's a chance that I'm going to waste a bunch of time here trying to find out. And honestly, if it doesn't work out, I'll probably do some video editing, but let's give it a shot. I'm going to write down 10, negative 15, negative 16, and before I waste a bunch of time, I'm going to double check. 3, 2, 1, 0. Okay, they're all here. I should also stop and check, can I factor anything out of all of these? And the answer is no. 15's not even, so I can't take out a 2. 16 I can't divide by 3 or 5, so I'm stuck. Okay, so here's what I'd like to show you right now. There's a thing called, I think it's called stacked, although my memory is failing me right now, but stacked synthetic division. So what I'm going to do is instead of writing a box, I'm going to draw a line. I'm going to draw a line right here. So I'm going to still do synthetic division. I'm going to start with 1. The only thing I'm going to do a little bit different, I'm going to bring down the 10 just like before. Okay. Now I'm going to do 1 times 10 is 10, but I'm not going to write that 10 down. I'm going to do the rest of that in my head. So 1 times 10 is 10, negative 15 plus 10 is negative 5. I'm going to write the result down. 1 times negative 5 is negative 5. Add that, I get negative 21. 1 times negative 21, when I combine it with 12, clearly isn't going to equal 0. So I know that 1 is not one of my answers. So what's the benefit here? The benefit is now I can just sort of scratch this line out and I can keep going. So now I'm going to try negative 1. I'm going to bring the 10 down. I get negative 10 is negative 25. This isn't looking good. Negative and a negative is positive. So I get positive 25 and 16, which I believe is going to be a positive 9, which is going to give me a negative 9, which is not going to be 0. That one doesn't work either. I'm going to try 2. I'm going to bring down the 10. 20. I get 5. I get 10. Ooh, this is looking good. I get negative 6. Negative 6, I get negative 12. I get 0. Hallelujah. Found it. So 2 is one of my zeros, meaning x minus 2 is one of my factors. So I'm just going to, again, spell this out. What I started with was this. And I have now factored it into x minus 2, and then a quadratic of 10x squared plus 5x minus 6. The goal is the same. I want to know when it equals 0. So now this factor leads to the 2 that I already found. Now I'm going to try and factor this guy. So let's see here. 10 is 1 and 10, 2 and 5. 6 is 1 and 6, 2 and 3. I'm looking to subtract to get a 5. I'll start with my 2 here. I get 2 times 1 is 2 and 30. That's not going to work. I get 5 and 12. 7 minus, that's 7, not 5. Let me do that again. 12 minus 5 is 7, so that doesn't work. So now I'm going to do 2 times 2 is 4. And 5 times 3 is 15. That doesn't work. 5 times 2 is 10. 2 times 3 is 6. That doesn't work. Ooh, this isn't looking good. 10 times 2 is 20 minus 3. 30 minus 2. I don't think this factors. So what are we going to do? I still want all the real zeros. So now what I need to do is I got to solve this some other way. So I have 2 choices. I could use completing the square. And honestly, completing the square looks pretty nasty on this one. I'll try and lower this. Let's go ahead and try it, though. I want to know when 10x squared plus 5x, oops, where's my 5? Minus 6 equals 0. I'm going to factor out the 10, leaving me with x squared plus 1/2 x. Close the parentheses. I got the minus 6. I'm going to slide my 0 over. Half of a half is a fourth. I'm going to square a fourth. I get 1/16. So I'm going to add in 1/16. Now I'm going to come around and subtract 1/16, but 1/16 times 10. So that's subtracting 10/16, which reduces to what? 5/8. So I know this factors into, and then I need a common denominator. So I'm going to multiply by a little 8 over 8 here. And I've got 48 over 8. So 48, negative 48 and 5 is going to be what? Negative 53/8 equals 0. Add 53/8. Divide by 10. I get x plus 1/4, the quantity squared. Multiply by 1/10, and I get 53 over 80. I'm going to take the square root. I get positive or negative, the square root of 53/80ths. And then I'm going to subtract 1/4. All right, so let's just kind of stop and or pause here. It asks for all the real zeros. Okay, so we did not get an imaginary answer out of this. It all worked out. So there are 2 more real zeros here because there is an answer to this question. And if I grab my calculator, I can get an estimate of what that is. So I'm going to do the square root of 53 divided by 80, which is about 0.814. So I've got x equals, we'll go all decimal here, 1/4 is negative 0.25 plus or minus 0.814 approximately. So I notice I have this equal sign right here. I really should come back here and get rid of that equal sign, because as soon as I threw in that approximation, it no longer was equal. So now I just need to add this to 0.25. and I get x is approximately equal to 1.064, and I get x is approximately equal to, actually that should be negative, excuse me, and then I've got approximately 0.814 minus 0.25, and I get approximately 0.564. All right, so what are my zeros? X equals 2, and then I've got these two numbers. Okay? And now, if it doesn't ask for anything but exact, you can give me exact. That's fine. This is a more exact answer, even though it looks crazy. And then if it asks for it, or if you feel like it, you can give me the decimal in addition. So what does it tell us about this graph? I knew that as a cubic function, it had to at least have one real zero, right? It had to look something like this at most. But it turns out what we have is actually that this bend here looks like it comes down. Now I haven't placed the location right, but now we have 3 zeros. Okay. All right. Example 3, find all the zeros. Here we go. P over Q, I'm going to just kind of jump ahead and make my list. So 10 is going to be 1, 2, 5, and 10. Q is a very nice 1. So my list is just positive or negative 1, 2, 5, 10. All right, let's get started. I'm going to do 1, negative 5, negative 5, 23, and 10. I'm only going to test about 8 numbers here, so I don't necessarily need to do my stacked version, but I'm going to do it again to practice it because I'm a little rusty. I'll start with 1. Bring down the 1 first. Now multiply and add. I get negative 4. I get negative 4. I get negative 9. I get negative 9, which is going to not be what I need to get 10, right? Because this isn't going to be, it's not going to be a negative 10, which is what I would need, so that's not going to work. So as soon as you know it's not going to work, as soon as you're sure, just give up on it and move on. Let's try negative 1. Bring down the 1. Scratch that out. I get negative 6. I get positive 6 gives me 1. I get negative 1 away. Negative 1 is going to be what, 22? That's not going to work. Throw it away. Let's go to 2. 2 is negative 3. Negative 6 is negative 11. 2 and negative 11 is negative 22, which gives me a 1, which is not going to work. Scratch it out. 1, negative 5, negative 5. And now I've suddenly realized I haven't checked something, but it's actually fine. But I realize I'm a dum-dum. 4, 3, 2, 1, 0. Okay, everything's there. And I've written it down correctly. Okay, let's keep going. Oh, why did I do that? Okay, sorry, wasn't thinking. Bring down the 1. I get negative 7 this time. I get positive 14, which gives me 9, which gives me negative 18, which gives me 5, which gives me negative 10, which gives me 0. Okay, so I know that x plus 2 is a factor, and I know that I've got something that's still x cubed, right? Because I went from x to the fourth, it divided by x, so now I've got something x cubed. I don't know how to factor something x cubed on my own in most cases, so we're still here in synthetic division, except now I'm going to draw a line right here, and now I'm going to use these numbers and not these numbers, because now I'm trying to factor this guy. All right, we're going to need some room here. Let's go. Come on. Hold on a second. My screen has, there we go. Still not behaving right, so let's leave the window and come back. All right, let's go. All right, so one bit of advice here is just because you got the negative 2 to work doesn't mean the negative 2 can't work again, right? It could factor into x plus 2 squared. So in other words, the minus 2 could work again. And honestly, the first time you don't check it, it's the time it's going to work. All right, but focus here instead. Bring down the 1. I get -2 makes -9. I get +18 isn't going to get me down to a 5. So pretty sure that's not going to work. I'm going to give up on it. I'm going to go to 5. Bringing down again. I'm going to circle this because I have a feeling I'm going to forget. I'm going to jump all the way up here. Bring down the 1. I get 5 is -2. 5 and -2 is -10. Gives me -1. Gives me -5. Gives me 0. Awesome. So I now know that factors further. Where'd that go? That factors further, and now I know we also have x minus 5 as a factor, and this goes with it. Seriously, a lot of stuff just disappeared. That's a remainder of 0. Okay, so now I've got x squared minus 2x minus 1 equals 0. I'm looking for numbers that multiply to be a 1 and subtract to be a 2. That feels impossible to me, so that will not factor further. So if I want to find the rest of the zeros, unless they're imaginary, they're going to be irrational. But the good news is I have the quadratic formula or one of my other methods to solve this. So I have x squared minus 2x minus 1 equals 0. I'm going to use completing the square, so I'm actually going to set this up a little differently. Half of -2 is -1. Squared, I add 1. I subtract 1. God, my computer is really going slow here. 1 second. All right. So again, I took half of -2, which is -1. I squared it. I added 1. I subtracted 1. There was already a -1 in the problem, so that's that one. So now this factors into x minus 1 squared minus 2 equals 0. Add the 2 to both sides. Take the square root. I was really misbehaving here. And add 1. All right. So I have zeros of -2, +5, and then 1 plus the square root of 2 and 1 minus the square root of 2. So we're going to go ahead and leave it there, unless I'm asking for something different below. B, write the p of x as a product of linear factors. All right. So that means p of x I have factored into, kind of like I was writing above, x plus 2, x minus 5. And now I want to focus on the linear factors piece. Linear factors, this is a quadratic factor. So that's not what it's asking for. It wants this factored down further as linear factors. So how am I going to do that? Well, now that I know the zeros, what I'm going to do is just like I did over here. Okay, so we didn't see it, but I set x plus 2 equal to 0. I set x minus 5 equal to 0. I subtracted 2, and I added 5. Come on. I think I need to restart my computer here. X equals 5. So I'm at the x equals stage, right? X equals, x equals, x equals. So if I want to recreate the factor, what do? I take the 5 and I put it back so it equals 0. So I'm going to move the 5 back, and I get x minus 5. I'm going to move the -2 back. I get x plus 2. I'm going to take these two guys, 1 plus the square root of 2. I'm going to separate it from 1 minus the square root of 2. And I'm going to do exactly the same thing I did above. I'm going to make it so it equals 0. So I'm going to subtract 1, and I'm going to subtract the square root of 2. So this right here is a linear factor. It's a weird one. And over here, I'm going to subtract 1, and I'm going to add the square root of 2. So this becomes a linear factor. And if I multiplied all that back together, I would end up right back where I started at P of x. Okay, this video is getting really long. Part C, sketch a graph of P of x, including the correct shape, end behavior, and intercepts. Okay, here we go. I'm going to take a look at my function, if it lets me. Come on. All right, even function, y-intercept is 10, leading coefficient's positive. So far I know my y-intercept is here at 0, 10. Wow, I think I'm about to crash. I better get done quick. All right, I have zeros at -2, +5, and then I have 2 irrational zeros. I probably ought to turn those into decimals. So let's do that. 1 plus the square root of 2 is going to be pretty small. So it's going to be less than 5 for sure. So I'm going to be in here at 1 plus the square root of 2. And then 1 minus the square root of 2. The square root of 2 is bigger than 1. So 1 minus that's going to stick me right over the other side here. So there's your 1 minus. Multiplicity is even or is odd on all of them. So my graph should look something like this. And that's 1 minus the square root of 2. All right. Feel good about that. I'm not going to grab the calculator after all. Looks good. All right. Let's see what's left. All right. Wowee. I really overdid it today, didn't I? I will probably filter this down for the class lesson because this is too much in one day. All right. This is a challenge question here. So find the domain of f of x. So take a look at f of x. And if you will recall, let me zoom out a little bit here. Again, I need to restart my computer. Okay, if I zoom out here, I will ask you to realize that p of x is the same function we just messed with. And so what do I need to know in order to answer the domain? I need to know when is p of x greater than or equal to 0. So when is p of x greater than or equal to 0? Well, if you recall, we just graphed it, and there it is. So p of x is this picture, and I want to know when it is bigger than or equal to 0. Because whenever it is, that's part of the domain because I can take the square root. So it looks to me that the domain is going to be all the x's such that x is an element of -infinity to -2. And actually -2 is included. So let's get rid of that, square it off. But then I go negative for a while, but then I'm going to pick things up again and be 0 at 1 minus the square root of 2, or its decimal equivalent, all the way to 1 plus the square root of 2. Then I go negative again, and then I pick things up again at 5 and go to infinity. So that should be my domain, because that is all these x values. That is when this thing is above the axis, right? So that's when the output is positive. Okay, and then finally, since it's here, I'm going to go ahead and finish this video. which is probably about an hour long now, and nobody's actually still with me, nor is my computer at this point. All right. Find the rational zeros of this one. All right. The good news is there's not many to check here, so this should be fast. So the possible P over Qs are simply the factors of 1 over the factors of 1. Guys, there's two numbers to check. So I get synthetic division. Oh, I'm missing a 0 here. So 1, 0, 1, 1. I'm feeling like the positive won't work because I have no negatives here. So how am I ever going to get a subtraction? So I think if it works, it's going to have to be the negative. I get -1. I get 1. I get 2. I get -2. I get 0. Oh, that was silly. That's not what I meant to say. I get -1. That didn't work. Just to make sure I'm not crazy, and I'm not, but let's just be complete. I'll try +1. I get 1. I get 1. I get 1. I get 2. I get 2. I get 3. That also does not work. So what did we learn? Does this have a real 0? Yes. It's x cubed. It has to have a 0. That just tells us irrational. So we know that is going to pass one time. So it's probably going to look like this. I suppose it could actually be this, and all of them are irrational. And really, the only tool we have at our disposal right now would be to use a graphing calculator. So if I were to use my graphing calculator and do this, I would see that once again, there are no rational zeros. I don't have my calculator pulled onto the screen right now, so I'm just doing this on my handheld. I'm going to graph it real quick. X to the third plus X plus 1, zoom standard. Okay. And the graph looks like this. Comes up, it does a little hitch, and it goes through, and it has a 0 right there, which we can calculate. Second function, calculate. Number 2 is 0. It asks me to go to the left of where I'm pretty sure there's a 0. Go to the right. Scroll back in between. And I get a 0 at approximately -0.6822328. So find the rational zeros. None. All right. We'll see you on the next one.